Hey everyone. So this is the assignment for Machine Learning Foundations for Product Manager course from Duke University on Coursera. We were given a data set and tasked to create a suitable model in order to predict power outputs for a electrical plant. I'll move on. So after reading the data, we have found that data was a labeled data, as we knew that the first four columns belong to temperature, vacuum, pressure, and humidity kind of things in order to generate the electrical output. And we also noticed that the target variable is numerical in nature, which is also continuous and not categorical, which means regression would be the best suited algorithm to predict any kind of such data. And we also knew and found out that we do not have to predict any class or category as an output, and hence classification cannot be used. As an output metric, we are going to use mean absolute error and mean squared error. Moving on, model building. Features that are used are the first four columns of the data, that is temperature, exhaust vacuum, ambient pressure, and relative humidity. uh, Algorithm, first we actually saw whether the uh, independent variables or features are somehow correlated with the target variable or not, and that's why if you can see the uh, first grid on the left hand side just below the text, I have plotted the correlation between each one of these variables against the target variable, and as you can see the values are significantly uh, considerable, meaning they are linearly correlated. And that's why a multiple linear regression would be the best fit to tackle such problem. Moving on, model evaluation. We have first splitted the data into two parts: 80% testing and 20% for, my bad, 80% for training and 20% for testing. In the entire 80% training data set, we have again splitted the data into four different sizes, wherein um, uh, each uh, each split has 20% of the data for validation purpose, meaning we will be doing cross validation. And while doing the cross validation, we found out uh, that model 4, as you can see in the below table, model 4 has given an output with the most high value for multiple r and r square. Multiple r tells us how better is your model in terms of fitting it to the equation or to the curve, and r square tells us how well the variability of the target variable is explained by the independent variables. So depending on these two values, we also compared mean squared error, absolute error, and absolute percentage error as well, but there was no significant discovery in order to uh, identify or differentiate which model can be used as the final model for testing the hypothesis. And that's why we went on with the model number 4, which uh, stood out to be the best one, as you can see in the future slides. uh, this model interpretation, as you can see, mean square error and mean absolute error is significantly negligible, meaning there is no error, and model has fitted very well with the predicted values. I have also given an equation with the actual values of the coefficient and the constant, and that is why I think it is recommended to use multiple linear regression for such kind of a data. Had this model not produced uh, uh, this level of error, we would have tried and tried and figured out any other way of evaluating the model, or choosing a different algorithm, but that was not the case, and that's why we rested our case here. And as you can see, This is the equation, and these are the values for the coefficients and constant.